All right, for this assignment, I just want to prove a couple of new identities off of our identities sheet. Before we get started, I want to remind you that we do have the sum and difference identities for both sine and cosine. A couple things to point out for cosine. The identities breakdown is cosine, cosine, sine, sine, and it's the sign in the middle is going to change from plus to minus or minus to plus. The identity for the sum and difference of angles in a sine is going to be sine cosine and cosine sine, where the plus in the middle is going to be the same. So if we're adding those two angles, we're adding the two products of sine and cosine. If we're subtracting the angles, we're subtracting the two products. All right, let's get into it and prove that the sine of negative x is equal to the opposite of the sine of x. First thing to do is to recognize that sine of negative x, that negative x is 0 minus x. That allows us to use the sum and difference identities for sine. The difference identity for sine is sine cosine, so sine of 0, cosine of x, minus cosine sine. So cosine of 0, sine of x. Then we evaluate these. The sine of 0 is 0. And the cosine of 0 is 1. Simplify this expression, and what we're left with is negative sine. So the sine of negative x is equal to the opposite of the sine of x. A very similar one is proving that the sine of pi over 2 minus x is equal to the cosine of x. And we're going to do that in the same way using that difference identity, that sine of pi over 2 minus x, that's a sine cosine, so sine of pi over 2, cosine of x, minus cosine sine, cosine of pi over 2, and sine of x. Now when we evaluate, the sine at pi over 2 is 1, and the cosine of pi over 2 is 0. So now it's the second term that's going to cancel out, and we're just left with cosine. So we do have that sine of pi over 2 minus x is equal to cosine. And there's just a couple more proofs that we use earlier identities in order to prove these identities.